Welcome everybody to yet another episode of Physics Speedrun. I am WeiEn Physics, and today once again I'm trying to finish 20 multiple choice questions within 20 minutes. If you would like to try the challenge with me, the link to the worksheet is down in the description below, or you can click on the link right up here. If at any time I'm going too fast, you can always pause the video, go back to the start of the question and repeat it as many times as you want. You can also change the speed of the video using YouTube's own video settings. So without further ado, let's begin. I have my calculator right here and I'm going to start the timer right now. The Bunsen burner is based on the principle of, the answer here will be Bernoulli's principle, right? In very simple terms, Bernoulli's principle states that in a steady flow of fluid, as the velocity increases, the pressure would drop, and as the velocity decreases, the pressure would rise. So in the Bunsen burner, when the gas goes into the Bunsen burner, it goes in at quite a high speed. So inside the Bunsen burner, the velocity is high and the pressure will be low. So now the atmospheric pressure, which is relatively higher, will be able to push more air into the hole at the side of the Bunsen burner, providing us with a more complete combustion. Okay, so that's B. If the pressure 50 meters underneath the sea is 5.75 times 10 to the power of 5 newtons per meter squared, what is the density of the sea water? So 50 meters underneath the sea, we'll use H rho g, right? So H rho g is equals to 5.75 times 10 to the power of 5, and the height here would be 50 meters. Rho is what we're trying to find, and g, let's assume it to be 10. So that's equals to 5.75 times 10 to the power of 5, and my rho would be 5.75 divided by 50 divided by 10, 1150. So the answer would be C. Next one. What is the principle used by an aeroplane? So again, it's the same thing. The aeroplane's wing is shaped in an aerofoil shape. Okay, so in an aerofoil shape, we will say that the air moves faster at the top of the wing and the air at the bottom moves a little slower, right? And so this causes the top of the wing to have higher velocity and lower pressure, and then the bottom of the wing to have lower velocity and higher pressure. And the difference in pressure would cause a net force pushing the aeroplane upwards. So the answer here is B. Figure 38 shows a spring balance and a wooden block that is fully immersed in water. What would happen to the reading of the spring balance when the block is moved upwards until the water level at P? So you can see here, the entire block is being submerged in water. So that means there is a buoyant force acting on the block, and the buoyant force is equals to the amount of water displaced, right? Sorry, the weight of water displaced, which is the weight of this amount of water, okay? And as you move the block around in the water, okay, doesn't matter where you move it, as long as the same volume of block remains in the water, the same buoyant force will act on the block. So you will still always get the same spring balance, okay, unless some part of the block starts to come out of the water, then you get a lesser buoyant force. So in this case, the answer will be remains constant. Okay, it will remain constant until the block is actually out of the water. Next, 50 milligrams is equivalent to what? So 50 milligrams, milli means times 10 to the power of negative 3. And we know that 50 is actually 5 times 10. So this is 10 to the power of 1 times 10 to the power of negative 3. I have positive 1 and negative 3. If I add them together, I will get 5 times 10 to the power of negative 2. So this is D. Which physical quantity has the correct SI unit? So temperature, Pascal, no. Temperature is calculated in kelvins. Time will be seconds. Let me write it down. Time will be seconds. Mass in kilograms is correct. And length should be in meters instead of kilometers. So C. Next, when light moves from air to a glass block, what happens to the ray of light? So when light moves from air to a glass block, it will slow down, right? The velocity will reduce, okay? But the frequency would remain the same. Okay, the frequency will remain the same. So velocity reduced, frequency remains the same. The answer here would be D. Figure 1 shows a ray of light traveling through a liquid. So it goes from liquid to air. Calculate the refractive index of the liquid. So refractive index here, I'm going to use N is equals to sine I over sine R, whereby I will usually be the angle at air, okay, angle at the portion of air, and R would usually be the angle at the portion of the other medium, okay. And remember, for this rays, okay, for light, our angle is always measured from the normal. So we cannot use 160 degrees. We have to instead use 160 minus 90, which is 70 degrees to the normal. And we cannot use 125. We have to use 125 minus 90, which is 35 degrees to the normal. Okay, so here I will get sine 70 divided by sine 35. Okay, so sine 70 divided by sine 35, that is equals to 1.638, so 1.64. The answer is B. Next, a butcher uses a knife with a surface area of 0.2 meters squared to cut a piece of meat. If the butcher uses 20 newtons to cut the meat, what is the pressure produced? So this is a very basic. Pressure is equals to force over area, right? So pressure is equals to 20 newtons divided by 0.2 meters squared. 20 divided by 0.2 would be 100 pascals. The next one, figure 4, shows a beaker with a surface area of 50 cm square put on the table. The beaker is filled with water with density of 1 grams per cm cube. The height of the water is 5 cm. Calculate the pressure acting on the base of the beaker. So since the answers are all in pascals, I will have to change the density to kilograms per meter cube. Okay, and how do I do that? Is by taking 1 and from grams to, I'll put it this way, gram divided by cm cube. From grams to kilograms, I will have to divide by 1000. And from cm cube to meters cube, I will have to divide by 1000000. Okay, it's basically 100 times 100 times 100. Okay, because for every cm, when you want to change it to meters, you have to divide it by 100. So if that's cm cube, I have to cube the 100 as well. Okay, so basically what I'll get here is 1 divided by 1000. Okay, and when you divide by another divided number, okay, it's basically multiply. So you multiply by 1000000, and I'll get the density to be 1000 kilograms per meter cube. That is the density of the water. So the pressure acting on the base would be H rho G, right? So H, the height 5 cm, I'm going to change it to meters, that's 0.05. Rho, that's 1000, and G, again, I'm going to assume it to be 10. Okay, so 0.05 times 1000 times 10, that is 500 pascals. Okay, C. Next, a trolley of mass 3 kg is moving with a velocity of 20 meters per second. A puppy of mass 5 kg hops onto the trolley as shown in figure 18. So this one is a conservation of momentum, right? M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2, right? And since towards the end, right, after the collision or after the process, both of these things move together, so their velocity will be the same. Okay, so the mass of the trolley is 3 kg. The initial velocity of the trolley is 20 meters per second. The dog wasn't moving at all. Okay, yeah, we're gonna assume the dog wasn't moving at the start, so the velocity of the dog, that's U2, will be 0. So I'm just gonna put plus 0. That is equals to Now I'm going to combine both the masses together because their velocity will be the same. It will be m1 plus m2 multiplied by whatever velocity, the final velocity. So m1 plus m2 would be 3 kg plus 5 kg, that's 8 kgs multiplied by the final velocity. Okay, so I'll get 3 times 20 divided by 8. So the final velocity would be 7.5 B. In an elastic collision, which of the following physical quantities is not conserved? So momentum is definitely conserved, right? That's what we did just now, conservation of momentum. And total energy is also conserved, right? So if total energy is conserved, that means kinetic energy will also be conserved, right? So only velocity is not conserved through an elastic collision, okay? Next, Linda dries her wet umbrella by rotating it and stopping it abruptly as shown in figure 15. So what concept she's using is actually Newton's first law, because the water droplets, when you rotate it to one side, they will tend to want to continue traveling in that side, and when you suddenly stop it, the water droplets would continue to move and fly off the umbrella. Okay, that's the concept of inertia, right, which is also Newton's first law. Which of the following does not influence the momentum of a moving truck? So momentum is calculated using m multiplied by v. Okay, so only the mass and the velocity affects the momentum. The displacement does not. Okay, so that's B. Next, two forces of magnitude 6 newtons and 8 newtons act on a wooden block on a frictionless surface. The maximum and minimum possible magnitudes of the resultant force are. So the maximum would of course be both of these forces acting in the same direction. I'll get, for example, in this box, I'll put 6 newtons here and 8 newtons here, and the maximum resultant force would be the total, which would be 14 newtons. And the minimum force would be if they are both opposites. So 6 on one side, 8 on the other, and the difference would be 2 newtons, the resultant force. So the answer here is D. The figure below shows the same object on a level table. 4 different pairs of forces act on the object. Which pair of forces causes the greatest acceleration? The greatest acceleration of course comes from the greatest force. So we have to find the resultant force. So this one here, same direction, 60 and 30, the resultant is 90. The resultant for this one is 100. This one resultant would be 60, and the resultant here would be 30. So the answer would be C. Next, what is the principle? Wai Kong is a footballer. In a match, he kicked the football as shown in figure 35. Well, you can see that the ball here is being curved. So the principle to explain this phenomenon again would be Bernoulli's principle, right? If you kick the ball and the ball spins, okay, one side of the ball would experience a higher velocity of air and the other side would be slower, and again this will cause a difference in pressure, which will cause a net force. Next one, which of the following is true about the forces acting on the aeroplane? So F, we know forward force is called thrust, right? It's called thrust. U, the upwards force, is called lift. G, the backwards force, is what we call drag, right, or air friction. Okay, and W is weight. So the answer here would be A. Oh, last page, right? We're way ahead of our time, so that's good. A tractor traveling at a speed of 10 meters per second collides head-on with a bus that was traveling at 15 meters per second. The masses of the tractor and bus are 6,000 kg and 1,500 kg or 1,500 kg respectively. Calculate the final velocity of the two vehicles after collision if they stick together, right? So again, conservation of momentum. So the tractor, let's say tractor is number 1, okay, M1U1 plus M2U2. So number 2 would be the bus. Is equals to M1V1 plus M2V2, right? And since both of them will stick together, they have the same velocity, I can just write it as M1 plus M2V. Okay, so the tractor has a mass of 6,000 and the velocity is 10, right? Plus, now because they collide head on. That means they must have been traveling at opposite directions, okay, in the beginning. So I will put one of this velocity as negative. It's up to you which one you want to, okay, because in the end the answer would be the same. It's just that one you might get positive, I might get negative, and so on. But as long as you put both of these velocities as opposite signs, then you get the right answer. So I'm gonna put mass of bars is 1500, but the velocity as negative 15. Okay, and this is equals to the total mass of 7500 multiplied by the final velocity. So what do I get here? 6000 times 10 minus 1500 times 15 divided by 7500, and I'll get 5. Okay. Last one, a bullet of mass 20 grams is fired at 100 meters per second from a rifle of mass 250 grams as shown in figure 17. What is the recoil velocity of the rifle? Again, I will use m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2, right? Now, since in the beginning nothing is moving, so before the explosion, both velocities are 0. Okay, so I'll actually get 0 is equals to m1 v1 plus m2 v2. Okay, if I move one of it to the other side, right, I'll get let's say m1 v1 is equals to negative m2 v2, and let's put the bullet as 1 and the rifle as 2. So the bullet has a mass of 20 grams, that is 0.02, velocity of 100, that's equals to the mass of the gun, which is 0.25 kg, and the velocity, which is what we're trying to find. Okay, so the velocity here would be 0.02 times 100 divided by 0.25, and I'll get 8. Okay, and stop. 16 minutes 18 seconds. That's pretty good. Okay, so that is all for this episode of Physics Speedrun. If you enjoyed the video, remember to give it a like and subscribe to my channel for more physics related content. Also, you can check out all the other Physics Speedrun episodes on my channel. You can also share this out with your friends who you think might enjoy them. I'm WeiEn Physics. That was another episode of Physics Speedrun, and I'll see you next time. Remember, never stop learning.